Welcome everyone to our next video about Yocto project. In the previous video, we learned about Poki source tree. In this video, we are going to learn about Yocto build directory structure and also about different methods, conditions, and operators in Yocto. Yocto build directory structure usually contains following folders as shown in the picture above. You can create a build directory structure by just running the setup command. We will go through how you can create build directory structure when we will look in our practical examples. But right now I can briefly tell you about build directory structure. The first folder, Conf, contains configuration files that you can define image specification and layer configuration in this folder. Then downloads folder contains downloaded upstream tarballs of the recipes that can be used in the builds. state cache folder contains shared state cache which is used by all builds. Temp folder holds all the build system outputs. We will see more in detail when we will do practical examples what actually is inside this folder. Right now I'm just giving you a brief overview so that you are familiarized with this directory structure. Okay, so the main conf directory structure which I was telling you in the previous slide has two important files, bblayers.conf, which explicitly lists the available layers, and local.conf file, which set up the configuration variables, and you can override configuration variables here as well. We will use this file for our example and also bblayers.conf file. So both these files are important. As I said, that local.conf file has configuration variables. Some important configuration variables are following: BP number threads. It defines how many tasks Bitwig should perform in parallel. Its default value is the number of CPUs on your system. Parallel_make variable defines how many processes should be used when compiling. Its default value is also the number of CPUs on your system. Machine variable is used to define the machine the target is built for. For example, if you are building for RPi or QEMU, you have to define it here. In the build directory structure, there was a one folder temp. Now in the temp folder, following subfolders are important. Build stats folder contains build statistics for all packages which have been built. Deploy folder contains following output of the build, like you have the whatever is the finalized output, it should be in this folder. And inside this there is an images folder. Like inside the deploy, there is an images folder which contains the complete image built by Open Embedded Build System. These images are used to flash the target. Work folder contains set of specific work directory, and it is split by architecture. They are used to unpack, configure, or build the packages. It also contains the patch sources, generated objects, and log files. Then sysroot folder contains shared libraries and headers used to compile applications for the target, but also for the host. There are some keywords which you can use to modify configuration variables. We will just go through some of those methods. So the keyword append is used to add values after the ones previously defined to a configuration variable. It adds value without any space. This is important. Why? When you are appending something, you have to add that space. As an example, like if you have a variable image underscore installed. You can append it by writing image underscore install underscore append equal to. You have to make sure that like when you are adding a new value, you have to put the space. Like here we have the space before the busybox. This example will add busybox to the package installed on the image. Then keyword pre-append is used to add values before the ones previously defined. So it will add value before, not after, just opposite of append. It also adds value without any space. Below example, it will add the folder to set of paths. If this is difficult to understand right now, just like understand the concept. We will go through it in our later videos. Keyword remove is used to remove all occurrence of a value within a configuration variable. As an example, image underscore install underscore remove equals to itsu tools. It will remove I2C dash tools from image install configuration variable. So if it is defined in that image underscore install configuration variable, after this, it will be removed. And then there is one more thing, that you can also append the configuration variables by the machine name. Like your build system will try to look match for the machine name, and if it is matches, it will then define that variable. For example, if you have kernel underscore device tree underscore beaglebone, and then you define anything, then it will tell that, okay, if your machine is beaglebone, then define this, or that. Or you can do, like, you can also mix with other methods, like you can say if this is append this, if this is the machine. So let's look, if we combine all these methods, what will we have? If we have like image underscore install, and then we have like busybox mdd utils, and then we have image underscore install underscore append, and then we have drop beer, and then we have image underscore install underscore append underscore r/4, and then we define I2C dash tools. The resulting configuration variable will have I2C tools only if the machine is R/4, Raspberry Pi 4, otherwise not. But the append, which we define drop beer, will be included in both cases. So like the most specific variable takes precedence. So if you have defined two variables, image underscore install underscore beaglebone, and you have also defined image underscore install, if your machine for which you are building is beaglebone, then image underscore install underscore beaglebone will take precedence and it will be used. If your machine is not, then this variable will take precedence and it will be used. So you can define multiple configuration variables with machine names, and the one for which you are building will be used. In addition to different methods, various operators can also be used to assign the values to configuration variables. For example, E plus is used for appending in a configuration variable, but with space. Equal to plus means pre-append a value with space in a configuration variable. This one, dot equal to, is similar to append keyword. It's also append a value in a configuration variable without space, just like we saw the append. Equal to dot, it's like a pre-append keyword. It pre-append the value without space. Similarly, equal to expand the value when you are using the variable. So when you are going to use it, then it will expand the value of that configuration variable. But if you define it colon equal to, it will immediately expand the value. And then there are two more important operators, question mark equal to. It defines or assigns the value if no other value was previously assigned to that configuration variable. So there is a configuration variable name, and if it was not assigned any value before, it will assign it now. Then double question mark equal to has similar, but it has one more thing, that it will assign the value if there was no value assigned before or even after it. We will use all these methods and condition variables in our practical examples. So right now, just familiarize yourself when we will use these in example. Just remember what's the purpose of these operators and methods or condition which we saw before. In the next video, we will go through bit-bake execution tasks, how you can run those tasks, like some commands, and also we will see how you can define dependencies between different layers. So hopefully you will watch our next video.